19.2. The Cavendish Experiment. In the last video, we learned about Newton's law of universal gravitation. This is shown by the formula Fg equals g m1 m2 divided by r squared. Newton never actually found the value of g, so he was never able to use his formula completely because he never knew what g was. 100 years later, Cavendish found a value for g. The Cavendish experiment is a very famous experiment in physics. Cavendish set up his experiment to determine the value of g. In the Cavendish experiment, two masses of known mass, little m, were suspended from a piece of wire. They are placed near but not touching two larger masses, known mass, capital M. The force of attraction between little m and big M was measured by determining the torque on the wire, how much the wire rotated as the masses moved closer together. The original distance between the two masses was measured. The force was g m times big M divided by the distance between them squared. And this rearranges to give us big G equals force times the radius between them squared divided by m times big M. This allowed Cavendish to determine G equals 6.67 times 10 to the minus 11, and the unit for this is the Newton meter squared divided by kilogram squared. But where does this unit come from? Well, if we look back at the original formula, this is newtons times meter squared divided by kilograms times kilograms, which gives us a Newton meter squared per kilogram squared, which is the unit of capital G. The paper that Cavendish published was called Weighing the Earth. And he called this because by finding the value of g, he could determine the mass of the Earth, something that seemed impossible at the time. For example, the radius of the Earth is known to be 6.37 times 10 to the 6 meters. Use this to calculate the mass of the Earth. So if we have the Earth, and a little person standing on the surface of the Earth, and we know the Earth's radius, we know that the person is attracted to the Earth with the force of gravity. Let's call the person's mass little m, and the mass of the Earth big M. The force of gravity on the person is g, mass times mass, divided by the radius of the Earth squared. But we also know Fg equals mg from our previous studies of physics. So mg equals g mm divided by r squared, and since small m appears on both sides, it cancels out. This just gives us g equals g m divided by r squared. So m equals little g r squared divided by big G. This gives us m equals 9.81 times 6.37 times 10 to the 6 divided by 6.67 times 10 to the negative 11. Which gives us a mass of the Earth equal to 5.95 times 10 to the 24 kilograms. Both the values, radius of the Earth and mass of the Earth, are found on your Physics 20 formula sheet, so you're expected to be able to use them on tests.